Hi, welcome to clickmyproject.com. The title of our project is Real-Time Rendering for Massive Terrain Data Using GPUs in the domain Image Processing. Let's see the brief explanation of our project. Here we are rendering a terrain data with Tessellation shader and geometry shader. To tessellate a quad patches, rendering is a process of generating an image from a model. Here we propose a terrain rendering technique we implement with displacement and normal map, and we could tessellate a core-based mesh with high resolution texture with displacement and normal map. Here, tessellation is a process of creating two-dimensional plane using a repetition of geometry shape with no overlaps and no gaps. We are viewing a terrain data from a height, but we are unable to view a terrain data. But in propose, we implement with tessellation shader, so we could view a terrain data. In existing previous GPU, access to provide only vertex and fragment shader. In existing, we couldn't view that real rendering image. In propose, we implement with CG shader and compute unified device architecture. We are viewing the terrain data from the height, but we are unable to view a terrain data. We implement with tessellation shader and geometry shader, so we could view a terrain real image. We made displacement a normal map. We displace a render image and tessellate in each quad patches. To view a terrain data, we implement with 3D visualization terrain data. Here, terrain data is a vertical or horizontal dimension of land surface. Let's see the flowchart of our project. At first process, the terrain image is viewed from the height. We could see only the render image. Here, render image is a process of generating image from a model. Using the implementation of tessellation shader, the tessellation is made with each quad and patches. Then we are calculating a shader in each vertex with the help of displacement and normal map. Normal map is for the render image, that is a real image found at the beginning. And next is a displacement map, that is a next step of render is a tessellation process is called a displacement map. And now we got a terrain visualization. Now we could visualize a real terrain visualization. And the next process, we could view a 3D terrain data. Now we got a rendering result. Let's see the demo of our project. This is our first module, rendering. The control is given to the key R. Pressing the key R, we are viewing this image. Now we are viewing the rendering object, that is the object is viewed from a height. Now we are visualizing the image which is not clear. Rendering is a process of generating image from a structureless object, that is this is a structureless object. Now we are going to implement this with tessellation process. Let's see our process. This is our next module, tessellation. The control is given to the key T. By pressing on the key T, we could view this image. Tessellation shader can tessellate a triangle or quad patches to improve geometrical shader. Here, tessellate in each quad patches, and now we are nearing the view terrain data. Tessellation is done with repetition of geometry shape without no overlaps and no gaps. This is our tessellation. Tessellation is made with each quad patches, and we could not view a real image, but by tessellating a rendering object again and again, it's possible to view a real rendering image. This is our next module, that is shader. Shading is made with in each vertex, that is using normal and displacement map. Normal map is a map which we've seen at the beginning, that is our render image, and next displacement map is a map which we seen at the second module, that is our tessellation. With the calculating with the shading vertex of each normal map and displacement map, we could got a shader. We got a tessellation shader. The control is given to the key S. By pressing on the key S, we could view this image. This is our next module, that is terrain data. This is our terrain data. Terrain is a vertical or horizontal dimension of land surface. This terrain view is only viewed from a height map, that is we viewed from a satellite. We got a render image. By tessellating each quad patches, we got this terrain data. The control is given to the key T. By clicking on the key T, we could view this image. Our next module is 3D terrain visualization. This is our 3D image. This is our 3D terrain visualization. The control is given to the key up. up, down and left and right arrows. Terrain data is viewed in all focus. The terrain data is repeating, and now we could view the real rendering object. This is our real rendering object. Thank you.